recording is in progress. So dear all, a warm welcome to today's AIESEP Connect event. My name is Uwe Püse. I'm a board member of AIESEP. You might know me. I work at the University of Basel in the Department of Sport, Exercise and Health, and I will lead through today's event. Well, the pandemic is still determining our lives, including at the universities. At our university in Basel, working from home is still mandatory until at least the end of February. So I'm sitting at home in my home office and not in my office in Basel, and I'm talking to you from here. But the technical possibilities make it possible to stay in touch anyway. And that is an essential goal of AIESEP Connect, namely to stay connected, even if we cannot meet physically at the moment. Currently, about 50 people are connected from all over the world, including today's speakers. And I would like to introduce them briefly to you. So first, I would like to introduce you Katharina Peschke. Katharina Peschke is graduated in physical education with a degree in movement and sport science, and she did a master in psychology. Finally, she also did a PhD in philosophy in Germany, in Berlin. Currently, she's an associate professor at the University in Rome, and her main research focuses on exercise and cognition across the lifespan, rise and fall of motor coordination and enhanced physical education. I could say a lot of things about Katharina. We are in touch already for a long time, but the most important thing is she is the mind behind the Joy of Moving method for holistic child development through physical activity. And this is promoted by the Italian Ministry of Education. It is indicated as a best practice in the recommendations for physical activity of the Italian Ministry of Health, and now in the scaling up phase in several countries. So this is one of the reasons why Katharina is here. And also I would like to introduce you to Sebastian. Sebastian Ludica is 35 years old. He's German and now for 5 years working with us in Basel. So he's a team member of our team. He was a postdoc researcher and he just finished his habilitation. Some of you might not know what habilitation is, but it is a must if you want to become a professor in the German-speaking scientific community. He has 2 kids and he's a young, productive researcher who focuses on physical activity and the brain. Well, from my experience, also with my students, it is important to say something about the so what at the beginning of an event. So why are we here today? Why are we addressing this topic? What does this topic have to do with us all? Well, for me, there are 2 main reasons for this. The first concerns the scientific discipline that unites us, namely sport pedagogy. From my point of view, this discipline had the shortcoming in the past that it is often not evidence-based. It is often dataless. That is why we often had a difficult standing among other scientific disciplines. An example, when we advocate the concept of active schools, critical voices say, yes, that sounds good, but do you have any evidence? Are there any causal effects? Do these effects exist regardless what we do in school? Or is it just wishful thinking? Today, we will see if there are questions and answers for these questions. The second reason is our subject, physical education. We represent at school a school subject that is often perceived as less important. Hard critics reduce it to playing soccer. The contribution to a balanced holistic curriculum is questioned. Math is important. PE is nice to have. Sport pedagogy is an important scientific discipline. We have this opinion. We also have the opinion physical education is an important subject. But we are not only allowed to provide opinions, but also facts. That's why we want to turn to that now. What impact does physical activity have on cognitive processes? Can we really say active kids are better learners? That's why I proposed this topic for today's event. In Basel, Markus Gerber and I decided to make physical activity and the brain as one of our research topics. That's why we hired Sebastian. He will now make the start and give a more basic oriented lecture. Katharina will build on this and proceed in an application oriented manner. We agreed on this in advance. After my introduction, both will present for about 15 to 18 minutes each. We have decided not to hold the questions and answer sessions until after both presentations, since the two presentations are largely to be seen as a unit. At the end, there are a few closing words from my side. Now I ask Sebastian to get into the subject. Sebastian, thank you for your willingness to share your knowledge with the AIESEP community. The floor is yours now.
All right. Thank you, Uwe, for the introduction. I hope you can hear me well. So,
yes, perfect.
All right. First of all, Uwe already said we are working from the home office. That means I will also present from my home office, and I have some small kids. So if it gets noisy, they're working on their cognition. So just that you know. Okay, so I'm gonna share my screen now. So I hope you can see it. So there are different ways to address the question, are active kids actually better learners? And this really depends on how you see the link between physical activity and academic performance. So you could consider it as a direct effect, meaning that physical activity translates into, or more physical activity translates into better academic performance. But you could also think of it as an indirect path. That means there are some variables that actually mediate its influence. And we already know that academic performance is influenced by a lot of different factors, such as cognition, specifically executive function, also intelligence, motivation, and many other factors. So we already know that executive function has a high predictive value for academic performance, and the predictive value is even higher than maybe for intelligence. So our approach is that we think of the link between physical activity and academic performance as an indirect link. That means we think that more physical activity maybe translates into better executive function, which in turn affects academic performance in a positive way. So also that you know there are two different ways to address physical activity or the link. I mean, you could look at acute effects. That means temporary effects that are induced after a single session of exercise. And you could also look at the long-term effects. For this presentation, I will just focus on the long-term effects. So academic performance can be assessed with very different constructs. It could be like a reading test, a standard reading test, a mathematics test. You could look at grades, but there are also other factors that contribute to academic performance. For example, the actual behavior in the classroom. And in the previous study, we wanted to test whether the indirect relation really is there for off-task behavior. That means the behavior in the classroom. When you consider off-task behavior, there are different kinds of behaviors that we differentiate. That means we have noise, we have passive behavior, and unwanted movements. So any kind of behavior that does not really promote the learning approach. And we found out that more physical activity was linked with less off-task behavior. But when we included executive function as a possible mediator, then this link was no longer significant, which means that actually more physical activity was linked with less off-task behavior by executive function. This somehow supports that there's an indirect link, And in the next step, I would like you to show that the effects of physical activity on cognition and specifically executive function depend on a variety of factors. So first of all, executive function, I mentioned this a lot. This is a cognitive domain that summarizes different functions that are related to top-down control of behavior. For example, inhibitory control, working memory, cognitive flexibility, and maybe more complex tasks like planning, which combine several of these components. To address the moderating effects of different variables on the link between physical activity and cognition, we performed a meta-regression. That means we looked at all randomized control studies that exist. That means across all age groups and healthy populations. And then we investigated the general effect of physical activity interventions on the cognitive domains shown on the right. And we wanted to know which moderators actually influence the gains that can be expected. And we investigated several factors, for example, dose parameters like frequency of the intervention, session duration. Then we were looking at exercise characteristics like intervention type. We were also looking at individual differences, that means participant sex and age. And we produced different models, tested them, and from each model, the moderators that explained a significant amount of variance were included in the final model. So the final model is actually the one that includes the variables that actually influence the effects. And as you can see here, that's the final model that's displayed. We find some design features that explain differences in the effectiveness. And we find some participant characteristics and also some qualitative exercise characteristics. So it might be surprising to you that we don't find any strong dose parameters. That means that the exercise duration, the intervention length, and maybe also the intensity does not really influence the effects that can be expected after a physical activity intervention. That means we should be less concerned about quantity, but maybe rather about quality. So as you remember from the model, there was a difference between sexes. That means we can see that generally the male individuals can get greater benefits from the physical activity intervention than female individuals. And this is even more pronounced when there's a progression of exercise intensity and duration. So that means if there's a progression, we can see that male individuals have even larger benefits. And for female individuals, the benefits can even be canceled. It's also important to know that we did not find a moderating effect of age, which means that the results are present for children, adolescents, but also for other age groups. Okay, you might also remember that that the exercise characteristics actually influenced the gains that can be expected. And here you can see the comparison of the different exercise types we included in our model. And as we can see, I mean, all of the exercise types that were included actually had a small benefit on cognitive functions. And when we compare them, we can also see that coordinative exercise had superior effects. That means it had a moderate effect size. And this means that coordinative exercise defined as additional cognitive or coordinative demands during the exercise may translate into better executive function, and that even more benefits can be expected after an intervention that includes this type. Okay, and the next step, we wanted to know, can actually everybody benefit from the exercise intervention, or are there any differences between individuals? I mean, we already know that sex could be a moderator, but we also wanted to know if there's a normalizing or maybe more enhancing effect. And to address this question, we did a pooled analysis on 3 randomized controlled trials. And we wanted to find out if actually children with a higher baseline or lower baseline cognitive performance can expect different gains from the physical activity intervention. And as you can see here in the diagram, the vertical line separates the children that have better than average cognition at baseline and worse baseline cognition compared to the average. And as we can see, we do not find much benefits in children that have cognitive performance that is better than the average, but rather we see that there are disproportionate effects for the children that have actually a lower baseline cognitive performance. This means that we can actually expect more a normalizing effect. That means the children that have a poor performance, they actually get better, which is good because we know that these need some help to increase their learning abilities. And we know now that physical activity really can contribute to this. Okay, so I've presented you some of the experimental studies or the results of the experimental studies. And you might think that there's a causal relationship. But actually, to really infer causality, we need to understand the underlying mechanisms. And there was recently a review of the mechanisms across age. And as you can see here, there are different levels, there are different mechanisms that are considered. And we don't know too much for youth. That means we have some indications, but it's not like we actually really know what's going on. But we can see that brain function is one possible candidate that may explain why more physical activity, or maybe more qualitative physical activity, translates into better executive function. So we actually investigate brain function along with cognitive performance in almost all of our studies. That means that's the main focus of our research. But we do not only want to know if actually exercise produces gains in cognition and learning, but also what kind of mechanism is responsible for this. And therefore, we usually include the EEG, which is a tool to assess brain function and specific cognitive processes that are associated with executive function. I just want to show you a sample task, which is the flanker task. And here, children are instructed to respond to the direction of the central fish by pressing a button indicating left or right. So we do this over many, many trials. And when the children see the stimulus, something happens in their brain. So here you can see time after stimulus. 0 seconds would indicate there is the presentation of the stimulus. And we usually observe what happens in the brain after they perceive the stimulus. And we separate different components. So we already know that there are different amplitudes, and each amplitude give us some information about underlying cognitive processes. And we usually focus on the N2 and P3. They can be separated as N2 is more a frontal component, and P3 is more a component that peaks in a parietal area in the back of the head. So what we actually did, we performed some randomized controlled trials and investigated the effects of different exercise programs on cognition, but also on brain function using the components I highlighted before. So in the first study, we were looking at the effects of marcher odds on inhibitory control and related cognitive processes. And we found that following a 12-week intervention period, that the participants in the intervention group actually improved their performance on the inhibitory control task. And when we were looking at the results of the brain function assessments, we also found that the exercise group increased the negativity of the N2. This means that their ability for conflict monitoring and detection has been improved. I mean, this makes sense that in martial arts, there is some change in conflict monitoring, because when you consider the intervention itself, they prepare movements and maybe they interrupt prepared movements because they see that the opponent changes his or her behavior. And that's conflict monitoring on a sports related task, but it also translates to more abstract tasks. And that's what we can see here. So actually, we see that conflict monitoring has been changed by the intervention, which is a process that contributes to cognitive control. In another intervention, we investigated the effects of a combined aerobic and coordinative exercise session. And similar to the other one, we found improvements in inhibitory control, but also in working memory. And this was an intervention that was included in the break time, in the school break time. So they participated in 20 minutes every day for a total period of 8 weeks. And we found these changes after just 8 weeks, which is quite a short intervention period. And again, when we were looking at the brain changes, this time we found no change in N2, but in P3. This component increased in its amplitude, which means that there was increased allocation of attentional resources towards the task. That means this better recruitment of attentional resources may translate also to other tasks, and especially to learning. And we can simply say that these two processes, N2 and P3, are often enhanced by the exercise intervention. So we don't have too much evidence in children, but if we go into young adults and older adults, we find the same effects. So this seems to be an effect that explains changes across age. So there are some important take-home messages. So first of all, I want you to remember that executive function actually predicts academic performance and learning, but also it's a predictor of mental health. And we all know that when mental health is affected, we also have consequences for learning and performance in many real-life domains. We also can say that there's a causal relation between physical activity and executive function. That means that if we have a prominent stimulus in physical activity, we can really expect benefits for executive function and related domains such as learning. Then when we look at the primary moderators, it comes clear that there are more specific rather than general effects, because we cannot expect the same gains in every individual. And also we have some differences regarding the exercise intervention. So this brings me to the next point, which is that the exercise quality rather than the quantity matters. And I just wanted to say that we know that coordinated exercise produces larger gains for executive function than maybe other exercise interventions. And this could be because coordinative exercise targets motor skills. So when we think of physical education, maybe we should make sure that the children actually really can improve their motor skills. So we should be concerned about the quality of physical education to be able to promote children's executive function and learning abilities. So that was my last point. This time it went well.
Yeah, thank you very much, Sebastian. It was not so easy to get back now to your presentation. Well, to summarize it a little bit from the big picture, Sebastian spoke especially about underlying mechanisms. For some of you who are not so familiar with this topic, it might be a little bit theoretical. But in order to build on that, with practical things, and as we said, Katharina will now build on that. It is needed to have these investigations, which Sebastian mentioned, And this is the floor for Katharina. For all of those who did not hear the presentation in the beginning, she is now in Rome. Katharina.
Yes, hi.
Thank you for joining us. I hope everything is fine for you. And the floor is yours now, Katharina. Thank you.
Thank you. First of all, Sebastian, my congratulations for all and for your humor, but above all of your great performance. He will be, in short, a leader in exercise and cognition research. He is already, but he will grow even more. I am the senior, so let's learn from the past what's next and give physical activity and cognition research some soul. Why do I ask it? I show you my objectives. So I wish to show you an historical view on physical activity and cognition research, from the detection to the nuances. Let's see what will be. And then, of course, Sebastian highlighted complementing the focus of physical activity dose with that of quality in physical activity and cognition research. And then Uwe told it is not so theoretical. I will ground it even more on searching for causal mechanisms that explain the effects of quality physical activity on cognition. Because from physical activity quality, we move then to quality physical activity, so characterized by quality. And then we should address the role of context to understand it better, because as a former PE teacher, I have always PE teaching in mind, and the context matters. So to bridge then toward holistic models of physical, cognitive, social and emotional development promotion through quality physical activity, which should be at the core of whole child, whole school and whole community perspectives. I start here. And then I recall that some scientists, relevant scientists in exercise and cognition research, Jenny Etnier, Yukai Chang, they told, okay, historically we had the signal detection stage in exercise and cognition research, where it was theoretical, mostly cross-sectional, small size interventions, but then a nature stage where a big approach from neuroscientists brought first relevant works on the specific nature of the effects, which Sebastian mentioned, so the nature stage. And now, after 2009, we consider a nuances phase in which Sebastian has very good explained how moderators and mediators complexify this relationship. We don't want to make it too complex. We want to address complexity, because without addressing complexity, we cannot transition it into practice. So it is a must. So in the detection stage, once upon a time, I was there. Only also to mention that before the big wave of neuroscience research in exercise and cognition from the States came, there were some pilot activities in the first 90 years in Italy with my mentors, and I also had some papers that time. Also, you can see the conditions of our first research when we had nothing. And of course, also further, I did a bit of research in neurosciences, event-related brain potentials, which were so now carefully mentioned by Sebastian. I moved away from that when already the big wave was coming, and also one of the biggest, Charles Hillman, a couple of months ago told Katharina, your previous work has inspired my PhD. So I was happy, and we can consider this big wave of the neuroscientists in the States at the end of the nature stage, when we move from the nature of this relationship, so the reason relationship, toward the specificity of a relationship. That is, first, they focused on aerobic fitness, academic achievement, and high-level cognition, which Sebastian already mentioned. So this is the threshold from the nature to the nuances stage. I will not discuss this graph, but have a look at the year 2009. This is the steep growing of exercise and cognition research, interventional research, focus on chronic exercise. We focus both on chronic exercise, so long-term effects of physical activity on brain and cognition. And the intervention studies have in the black line, you can see they were growing, and also reviews were growing. So we have the history where we arrived into the nuances, and now arriving into the nuances of this relationship, I published a little paper, which was instead a lot of times cited. And John Best wrote to me, "Oh, Caterina, this had inspired me about the quality of physical activity." He performed a wonderful review, which is cited 1,000 times and more, in which he told, okay, maybe not only, as Sebastian told, the metabolic demands of exercise impact cognition. This is relevant for PE teachers, because if it would be the only pathway which is relevant, then we would say we don't need to study a lot of times how to create quality physical activity, but you pay only attention on the quantity of intensity, frequency, regardless of which movements you use. So it would be very poor approach to exercise and cognition, with very poor implications for physical educators. So our qualitative characteristics of delivery wouldn't matter so much. But Best proposed the cognitive task complexity, the coordinative task complexity may matter in determining whether there is an impact. So this is what I called the dose-response relation versus quality-response relation. And I performed this review where I asked, please stop or not only work on quantity, because it's too poor for deliverers for whom quality matters. And there was some research, but of course, it also elicited some debate. Particularly, we have two souls in neurosciences of exercise and cognition. The one is exercise neuroscientist. The other is developmental neuroscientist. The ones are concentrated on physical activity. The others were concentrated on executive function development, how to ideate. And both converge on the value on physical activity. But this marriage was followed by a sort of divorce, because the developmental neuroscientist told, oh, there is too much hype about aerobic fitness, aerobic exercise, but there is not so strong evidence as we could mine. And of course, the American group replied, you can't distinguish mindful and mindless physical activity, because may you explain what mindless is? There is every time some brain in the activity. So this discussion, and then the reply again, no, aerobic exercise and resistance training have least effects. So this was a discussion, and I felt a bit as a punching ball in between as a reviewer, but it was interesting, but it could not bring us much further in understanding to apply. So I think that in this sense, marriage, divorce, beyond dichotomy, quality physical activity might be the response to join physical effort and mental engagement for practical purposes. For that reason, in Psychological Bulletin, Phil Tomporowski and I asked, please, we as physical education teachers, we look at quantity and quality. So we have not only frequency, intensity, time, but type also. And there are not only metabolic exercise demands, which have demonstrated some effects on the brain hardware, but we have also a lot of skill acquisition processes when we learn physical activities. So we have motor and cognitive exercise complexing affect and motivation playing in, as Sebastian wonderfully depicted. So I made some oversimplification on brain hardware and software, while they are both together and we cannot really distinguish them, but to have an idea that we can add the quality and have an impact on the brain health beyond the metabolic pathway. Even though, if you look at the literature on children, so we had the first position statement of the American College of Sports Medicine, positive. So we have positive conclusions. We have an influence of physical activity on brain and cognition, and we have to look at mechanisms to understand it better and apply. But part of these authors, together with other authors, so Uwe, me, and others, we came to different conclusions, inconclusive conclusions. So we don't know. Looking at high quality studies, we didn't know. What does it mean? Where is the problem? Only mathematics seemed to be fostered. The problem is, how can you look at causal mechanisms and understand why a growing amount of reviews is leading to inconclusive conclusions? So I can be happy as a senior after decades of research, and then we want to apply it and then say we don't know, we are inconsistent conclusions. So I underwent the biggest work of my life, never again. So a review of reviews where I looked at all over 200 selected primary studies of all these reviews concerning chronic exercise effects on cognition. And I wanted to understand not only with the systematic review, which is, so they were so growing, and I told, I fear that we are fishing in the same primary studies with many reviews, because every PhD student performs a review. But I want to give the review some soul. And the soul can be through a theoretically driven synthesis, as realist synthesis. I tried it, and I don't explain it because we have lost time with the hackers. But first of all, every review ends with the words, we need more high quality studies. I am not happy on that because I am an applied scientist and I am a former PE teacher. And so I looked, what is quality? First of all, in 90 reviews, 25 different assessment tools, which were more conservative, red light, or more progressive, so green light. And then even when the same study was evaluated in different reviews with the same tool, we had a high inconsistency. So we had about a crazy traffic light with the green, red, and yellow to say, what is quality? Why do we call for merely for high quality research, more high quality research? So I looked also at moderators as Sebastian because it's relevant. And so I saw all primary studies over 200 and where the moderators were addressed and if they found results. And you can see here from the strongest to the least strong evidence and consistent. And one thing which overlaps with the conclusions of Sebastian are physical activity with skill involvement deliberately set higher by specialist PE teachers. This means larger benefits. So motor skill learning challenges matter versus routine physical fitness exercises. And also comparator activities, one may say, okay, there is more engagement, motivation than business as usual, if you, but it is not related to the quality of physical activity. No, I could demonstrate that the strongest evidence with when the comparator is physically active. So what really matters is the quality of the physical activity, not no activity versus enriched activity. So it's relevant, and also group-based delivery type, and then the quality matters more. So the take-home message in this part is quality matters, skill involvement matters, cognitive challenges matters beyond the physical effort. I was not satisfied on that alone because, okay, we could estimate the consistency and strength of evidence of the effects of given determinants of physical activity across a range of moderators and also looking at mediators. But I wanted to add the theory-driven synthesis because there must be a complex interplay of moderators and mediators. And so the question for practitioner is why and how physical activity intervention work and in which circumstances and for whom, for which children. So the way I synthesize what works for whom, why, under which circumstances is called realist synthesis. And I was glad that 1 year later, exactly in the same journal, 2 further papers were published on realist review and complex interventions. This is relevant for application. This is a bit my model. I try to look at it. So I told maybe we find inconsistent conclusions and we don't know how to translate it into practice because given mechanism addressed by Sebastian may be triggered in some context and not in others. So it might be, for instance, that in a physical activity ecology here in the model, school setting, and if the delivery type is, oops, sorry. if the delivery type the delivery mode is in groups with social interaction, the delivery type is by experts who can really manage the quality of physical activity, motor coordination, cognitive challenges. So maybe that in this context, then we have the skill acquisition, and the children may reach the optimal challenge point, which fosters cognition. Maybe when the children are isolated or not in the social context, or the teachers do not really find the right challenge, then we don't have cognitive benefits. A nice paper of Mirko Smith, for instance, targets, so the title is Too Much of a Good Thing. If we put too much challenge, cognitive challenge, physical activity, it might be deleterious. And then we can also see from the most structured physical activity context to the least structured. So the virtual reality, there are immersion and presence, which might help have cognitive benefits as a mechanism. And also think about the social and physical environment. The physical environment in green can help also executive function. So we can have additive or interactive effects of making outdoor education. This only to say that this pattern is complex, but maybe given mechanisms are active in given settings. And we move toward the models which explain this better. Holistic models of physical, cognitive, social, and emotional child development promotion might be at the core of quality physical activity. This is the synthesis of my review, where I try to understand what are the mechanisms, what are the contexts, because this really synthesis looks at context, mechanism, outcome, configuration. So under which context may I have a mechanism functioning to improve children's cognition? And of course, there is a lot of research of the fact that a physically laden context, the physical activity, may enhance, foster brain changes through physical effort. But also from the developmental neuroscientists, we know that positive emotions have a positive effect on executive functions. So this is what I told, as I labeled as capacity boosting. We can boost cognition through physical effort and enjoyment as a pathways. But also, if we have physical activity, team games, martial arts, which are cognitively laden, and also socially laden in a social context, this can build executive function capacities which underlie complex activities and social engagement and social support. So, and also some special properties there are, but also restorative. Attention may be restorative in green environments. And this is so that we can improve cognition by boosting it, by building new skills, cognitive skills, and by restoring skills in the right environment. If you look at the context and the mechanism and the outcomes. Related to school, so if we have active breaks, fine, we can, they are not cognitively challenging, it doesn't matter, we can, they are physically laden, emotionally laden, and they can boost our children's cognition. But if we also embed cognitive challenges into the activity, then we have the physically active learning. So we embed challenges to learn while we move the pedal. And also mindful movements, there are special properties, special engagements seem to affect the brain in given forms. Mindful movements are those which we can be embedded in school activities. And lastly, what about outdoor education with thinking on the effects might be additive or interactive of the green environment or a facilitative environment and the physical activity. So looking at the school, active breaks and physical active learning, we have to intersect exercise and cognition and embodied learning research in a nice narrative review followed by a meta-analysis. Hopefully we will publish it soon. In the last stages, we can distinguish between activities which we bring to the classroom, but are not low integrately, so not related to the subject we want to teach children. and then they are low relevant and not integrated. So I stop learning, I make an active break, and then I restore training, learning. These are active breaks, low integration and low relevance. At the other end, you have high integration, high relevance. I put physical activity, I learn while moving, and my movements help me understand what I am learning. These are two relevant points we can exploit to use the physical activity benefits for cognition in the school. But of course, it is not enough to know which kind of physical activities, as in our meta-analysis, are best suited to improve memory, learning, and cognition, whereas active breaks or integrated physical activity, physically active learning. The next step to transition into practice is how can we convince physical generalist teachers to work with us and implement physically active learning? So this is an example of a work of a European network of physically active learning, and how the steps, what are the relevant steps to get teachers involved, especially having a whole child and a whole school and whole community supports. And so this is my last, second to last slide. So the whole child, whole school, whole community is needed to transition these ideas from neurosciences to application. And the holistic model should be where physical activity moves so promotes in every domain, as in my joy of moving. But the question, are active kids better learners? It depends, but it depends not only on science, it depends on us, a better understanding of what works for whom, under which circumstances, and how to transition it into practice. So my idea, which I published in an editorial I was asked to write just a couple of months ago, we need to further really our understanding and help the transition into practice. We need to perform research, giving physical activity and cognition research some soul. So with a focus of interest for us. And I thank you for your attention.
Thank you, especially Katharina. Well done. Well, because of the interruption we had, our time for question and answers is a little bit shortened now. Hopefully you can all understand. There are about 10 minutes left. So the time for question and answers is limited. Nevertheless, I would like to ask you, are there any questions which you would like to Sebastian or to Katharina? When you have a question, please say your name, where you come from, and keep your questions quite short, not a second presentation or third presentation, but really briefly. Is there a question anywhere? I have to check, I can't see everyone on the screen here. I don't see any questions at this time now.
Uwe.
Yes, please, Mark.
Mark Loes, AIESEP, University of Liège, Belgium. Thank you to both presenters. It was very, very interesting and so challenging for us as researchers, teacher educators, and of course, physical education teachers. Just a question for Katharina. You mentioned many times about quality. Do you have some very precise recommendation about what is quality in your mind?
Yes, thank you, Mark. Yes. I had to fly because it was too late in my gyroscope. So there is a physical activity which if you move, then you have outcomes proximally physical fitness, but how you move makes a difference in terms of motor coordination. What are the challenges? And the motor coordination is close to cognition. Cognition underlies the creation of new coordinations, and also the broader frame of life skills, social, emotional, which rely on executive function as well. From this perspective, quality physical activity is for me a quality which has demands in physical fitness, motor coordination, cognition, and social-emotional challenges. And how to do it? We have to understand with the task analysis, look into our, for instance, physical activity games. You have a game where you have, of course, some challenges because you are running, but then if you only run, so you have physical fitness, but you have only one type of motor coordination, only one type of locomotor skills. And if nothing happens, then you have a low cognitive engagement. And if you run alone, you have also no social engagement. So this would be poor. It would be rich only on one circle. If you put, for instance, a tag game where you have, I am Mark, you and Sebastian. I have to catch you, you have to catch Sebastian, Sebastian to catch me. So as a rock, paper and scissors. Then immediately I have to escape from you, but tag him on who is escaping from you. And this creates cognitive challenge. And if then I alter the locomotor skills needed and I change the rules, then I will engage motor coordination more, I engage cognitive challenge, and I engage also the social interaction, which is competitive and cooperative, because we are not only we three, we will be teams, and so on. And in that, and this is enjoyable, of course. And I think then you can alter the demands, because you can also continue, you can, for instance, think also in the constraint approach, you alter constraints on the actions. So you pose a problem to be solved, and then you have to solve that problem. And then you engage the working memory, you have to immediate routine actions, and then you have to find new solutions. And if you say, for instance, but now you stop without using the not stop on the feet, I have posed constraints, and the people will search for solutions where you don't stay on feet. In short, you will challenge spontaneously. I wanted to challenge cognition, but I am also challenging balance and coordination, because the children can know more. So being aware with task analysis, how you change the demands on our in a given domain, and you will have consequences also in the other domains. And then you can move the challenges forth and back to meet the optimal challenge point. This is what I mean.
Thank you very much, Katharina. We see the topic is very complex. We could speak for hours about that. Finally, a short question to Sebastian, so that you also get a question. Sebastian, you focused on long-term effects. There are also short-term effects. Can you just say a few words so that everyone understands what your research is focusing on? What is a long-term, what is a short-term effect? Can you link that to projects which you did?
Yeah, so actually when you look at short-term effects, it's just the effects produced by a single session. And as Katharina has shown, there are different ways to enhance learning and executive functions. We can have something like embodied learning. That means we integrate the information we want to learn into the exercise session. And that means we simplify learning by combining it with movements. That's one way to do it. The other one would be a more energetic approach, meaning that you just spend exercising, you have activating effect for maybe cerebral circulation and stuff like that. And you also promote executive function from a different or by a different way. So there are many ways, and it's maybe important to stress that the things that work in the long term may not produce the same effects in the short term. So for example, we found that when we have like a coordinative exercise session where the coordinative exercises are not linked with information that we want to learn, then for some people, the coordinative exercise can be like too stressing for executive function, because they already require some engagement of the executive functions. So for an energetic approach, it's better to have like a simple exercise task, something like aerobic exercise, and then you can expect effects for up to 2 hours, maybe more. It really depends on how long the bout is, but we found effects until 2 hours after the session.
Thank you, Sebastian. I think there are even a lot of more questions which we could discuss now, but as I said in the beginning, a good session starts in time and ends in time. And as we have a session later on with the AIESEP board, we have to come to an end now. Well, as we have seen, the topic is enormously complex and inspiring. So we could go on discussing it for a long time. It's really nice that we have so many participants. I've seen they come from really everywhere in the world: Uganda, Qatar, Australia, Finland, Lithuania, Turkey. So thank you very much for joining this year. Maybe it is a good idea to organize an AIESEP specialist seminar on this topic, Mark, maybe even in Basel, where we could just move into a brand new department building. A few months ago, Sebastian has a state-of-the-art laboratory for cognitive research there, which he would certainly like to show. As we have seen, today's topic has only been on the agenda for a few years. It's no comparison, for example, with cardiovascular research that has been going on for much more longer time. Nevertheless, this research showed enormous success within a short time. Both of our presenters today have been able to publish articles with an impact factor of over 20 in the last few months. So really congratulations to you both. It's amazing from our field to have an impact factor of over 20. And this in journals that are not focused on sport pedagogy or sport science, but are based in psychology, like Katharina, and cognition research with Sebastian. So in the Psychological Bulletin, or Sebastian just published in Trends in Cognitive Sciences. A special feature in this regard, maybe that is also new to you, in the latter journal, Trends in Cognitive Science, you cannot submit contributions, but you are invited by the editor to write a contribution on the topic as an expert. With today's event, we hope to have made a contribution that positively influences the scientific discussion and the scientific visibility of our discipline. And hopefully it can contribute to put the standing of our subject, physical education, in a different light. Because it becomes clear that PE is not just playing soccer, but can make an important contribution to the overall development of the child, and is therefore an important part of a balanced, holistic curriculum. So thanks to the speakers, Katharina and Sebastian, really well done. Thanks to Cassandra for facilitating the meeting. Thanks to AIESEP, Mark, and all the team for hosting this event. And last but not least, thanks for your interest. Warm greetings from Rome and Basel. The event is hereby over. Thank you very much.